can be there. So guess you'll get.
ऐसे नोट सिखाते हैं हमको.
So I'll give you, just in case कभी लगा तो you can just be here. Come here. For the most part, try to be there वैसे. नहीं इधर ही. Okay. All right, folks, we're going to start. So again, as Sudha mentioned, one last request, if you folks want to come in front, if you can hear us better. If not, if you're comfortable there after lunch, perfectly fine. I assure you, we will not put you to sleep, okay? It's going to be a fantastic talk. Okay, so with that, let me kickstart. My name is Amey Banarse. I lead the solutions engineering team here at Yugabyte. You heard from a lot of my teammates for the entire day today. The primary goal of our team is to actually work with customers and users like yourselves and take your data problem, help you with scalability and resilience aspect of your database, and actually help you be successful for your own businesses. So come talk to us. Most of my team is sitting in the back seats there. They're fantastic people to work with, and please do enjoy time with them. And with that, it's my pleasure today to introduce one of the most important speakers here, Gaurav Saxena. He's an automotive industry expert, a person who actually works on distributed systems for an automotive company. And the product that he builds actually affects lives of millions of consumers like ourselves who drive every day. So it's a very important thing to understand what an automotive industry leader goes through while building a platform which affects lives of millions of people, taking security, responsibility, best practices into consideration. And from his, I would say, career summary perspective, he's a solid hands-on leader. He's been working on cloud areas and stream-based architectures for several years now, and a huge fan of Kubernetes, I would say, as well. So with that, Gaurav, introduce yourselves.
Thanks, Amey, for the introduction. Hello, everyone. My name is Gaurav Saxena. I am based out of Bay Area. I work for a large automotive company. We help millions of vehicles to connect to our platform. I lead a platform engineering team at one of the, as I said, automotive companies. It's great to be here. I've been in Kubernetes space for quite some time, but this is one of my first Kubernetes extended event conference. So thanks, Amey, for hosting me here.
Great. So folks, the format of this presentation is a little bit different than others. We're just going to talk, and I'm going to ask some very hard questions to Gaurav. He's going to think on his feet and really respond to my questions. So it's going to be fun. You folks will get the chance to ask him questions as well for the last 5 minutes. So with that, let's start with this, Gaurav. What's top of your mind today? Given that it's your first KubeCon, you're seeing all the love and energy from Kubernetes and open source. How do you go about building a product for an automotive company?
Yeah. So, I mean, before I go into that, the space, I want to start with the preface. Everyone in this room will resonate with this slide here. So if you are from a startup company or enterprise company, no matter what, this is how our journey starts. It starts with a product lifecycle market fit. So when you are a small startup, you don't care about scale, you don't care about operations, you focus on building things. And then you succeed, and then you go off, and then you get a customer, you get a market fit, and then you shove the features into it. And then what happens next? Guess what? Your POC is in production now, right? So that's where the challenge starts at the scale. How do you think about from operations perspective? Why my POC was in production now, I'm getting fail whale every night? Why I'm getting constant pages? And how do I make a resilient platform or make my applications more reliable, right? So I want to talk about the challenges that as all of the software engineers in this room can resonate with this, and how we feel to tackle this problem in a very consistent manner that focuses on the developer productivity. So we admit that there's a problem, right? So think about that all the proliferation of the cloud services cost of complexity. So every team, every department have their own practices of building software. There is your teams may be in very silo. They may not be able to learn from their sister teams what's the best practices they have done. Every team has their own way of doing shipping and delivering software. What it results into is an increased risk of outages, right? Your MTTR, mean time to resolution, are over the roof now. I'm sure, and most of you in this room will be on an incident call bridge where you have 100 people and somebody would have asked you a question, did we deploy a thing in last 20 minutes? What caused the outage? Because there is no set of consistent dashboards. There's no set of metrics where to look for. So you are in this deep world of triaging and then troubleshooting the incidents from, right? So again, these are the problems and how we as a software professionals are trying to tackle this problem. That's what I want to go and present the next slide. Amar.
Perfect. So Gaurav, I've heard that the on-calls are going to go away with AI coming and taking over the entire thing. But until that is done, Gaurav, thank you for these insights. And actually, really appreciate the fact that you're admitting that there is a problem in the developer community. Yeah. And this puts a lot of toil on the developers and operators to really understand that. So let's go into how you have basically kickstarted certain initiatives to solve for these in your current large company. Yeah. And folks, just as a reference, it's a Fortune 50 company. So anything you do impacts all the developer teams in that case.
Correct. So I will start with this concept of called internal developer platform. It has been in the industry for quite some time. There is nothing new here. Everyone has their own definition of what internal developer platform, aka IDP, means. I will, from my own industry experience, I will share the insights, how to create an IDP platform with the best practices built into it. So let's start with what IDP is first, right? So it's a centralized development environment. So how do you do the development, deployment, testing, and operations? That's built into it. So think about that. You have two parallel teams. One is the application team, and there's an infrastructure team. Infrastructure team is very focused on Kubernetes, right? So when they speak, the platform engineers speak the language like pods, deployment, services, ingress, secrets. There's nothing application specific here. And now you have on the right side, you have an application team who wants to build an application, focus on the business logic, the thing that moves the company needle, the things that makes the company money. They should not be in the weeds of learning what Kubernetes is, as an example, right? They should be focused on, here's my application, how can I deploy this in a consistent, reliable way? So platform team, the focus on the shift left, have a high autonomy where anyone, whether you are an application developer, Node.js developer, if I want a database, I should be self-served. If I want my application to be run in a Kubernetes, I want to be self-served. I don't need to know the internals of Kubernetes. How can I abstract that details, right? So that's the core tenet of an IDP. Automation I talked about, right? Efficiency, collaboration and governance. So when we build, so let's, for example, I'm an application developer. I am writing a software. I want to be abstract away from all the security scans. I'm building an image. I want to pull from the artifact. I want to deploy it. I should not be worried about my security scans. That should be abstracted away from the platform itself. How many people, how many engineers in the company, they focus on the CI pipelines and making sure that it is secured and scanned, right? So that concern can be taken away from the applications team to the IDP platform. And again, it's not an opinionated stack. It's not something that you give your developers, hey, here's the thing, you go and run from it, right? So you build the right behaviors in the platform and then have developers focus on the business logic.
That's great. So help us understand the different components in your IDP platform today.
Yeah. So Kubernetes is the default de facto API platform. Many people understand Kubernetes just more of like a running containers, but it's more than that. It's an extensible API platform. So think about the core tenet of Kubernetes. You have a control loop, you have a desired state, you want to make sure that your current state matches with the desired state, right? So Kubernetes can control not just the containers, but think about, for example, you have a control plane, you provide an interface, an API, where you can interact with any application developer or platform engineer can use that interface to use the control plane to orchestrate, let's say, for example, databases, right? You have a schema. Can you make a schema management through control plane? Can you create the pipelines to deploy your images? Can you manage your AWS resources or GCP resources through the control plane itself? Right, so that's a core tenant on that. So you basically write the CRDs for it. The common platform is the cross-plane. If you heard about it, it's a CNCF project. Cross-plane is basically extending the Kubernetes API, right? So that's the core tenant there. On the left side, you have a Git. So think tools like, for example, Argo CD can synchronize your desired state versus what the current state of behavior is. And then, of course, you are managing your all the providers, whether it's AWS, GCP, any infrastructure, you're managing through the control plane. So what you have done here is for the application teams, you have provided them the abstraction. They don't need to worry about where their app is running. They can run in AWS or GCP. They don't have to focus on whether I need to run my workloads in AWS M5 machine, or is it M2, or is it T2 instance, and things like that. You have taken away those concerns. So they focus on the business logic, right? And it's a very cloud native, so you can deploy in any cloud provider in any region that you want. It's the same stack, very portable stack in that way.
That feels like a dream world for all the developers, right? So help us understand, while designing the IDP, keeping end customer as a developer and his productivity in mind, how did you go about building these internal components?
Yeah, so these are the 4 or 5 major components I would say here. So local development environment, right? So how do you write, for example, most of the companies have environments like dev, prod, stage, sandbox environment. But then when I think these environments, multiple environments, these are crutches, meaning you may ship a software and in prod environment and it fails, and you get asked question, why didn't test this in your sandbox? Well, there was maybe not a representative workload there, or the workloads were different then. So how can you consistently enable the developers to create the development environment? That's what the IDP focuses on. The standard SDLC, so you have a build, right? Build pipelines, then you have a tests, then there's a scan, then there's observability there. So observability plays a major role here. As I mentioned in the previous slide, that their IDP platforms also want to standardize your operations. So think about like a consistent semantic conventions of your metrics or traces and logs. So one of the CNCF project is OpenTelemetry, and how you try to plug in the OpenTelemetry with your cross-plane providers. Not only it collects the application metrics, but also the infrastructure metrics. So you're basically marrying both the application and the infrastructure metrics together. Portal and tooling is basically, think about like the tools here, like for example, Backstage, a framework from Spotify, or other framework called Port. So it's like a GUI interface. So if I want my engineers to not only create the infrastructure declaratively, but they can also use the GUI tools to submit their YAML manifest and see the changes on live environment. So that's the components of IDP there.
That's great. And let's talk about your core principles while baking this as well.
So security and governance, right? You have, when you are building a software, shipping it through CI pipelines, you want to make sure that it has passed the FOSSA scans, as an example. You are making sure that licensing of your third-party tools are in a way that's consistent to your policies, right? You want to make sure that your things like, for example, API, there's tools like Checkmarks and 42 Crunch. You want to make sure that your APIs are well designed and it is following your company guidelines. So can you build all of this in the CI pipeline itself? So again, you are abstracting away the details from your application developers and putting in the platform itself, right? Standardized disaster recovery. I mean, it's a major part of enterprise company. When we go and launch a production software, it has to be DR compliant. So can you again make it sure that it's very consistent for all the applications, all the workloads that you're launching? Centralized observability, I talked about it. Operations, yes. Then deployment and rollback strategies. So if I am, think about like the blue-green deployment or your canary analysis. How can you bake this into your deployment architecture? So you give the enough abstraction to the developers so that they can choose whether they want to go to canary deployment or a blue-green deployment as an example. Right? So again, these are the bells and this is built in the platform itself. And failover and recovery, part of the disaster recovery itself.
Got it. So Gaurav, you used the keyword abstraction, and so can you throw some light on like how are you really leveraging these abstractions to take away this overhead from developers? Like, what is a special sauce here?
Yeah. So in the abstraction, so I'll give the example here first. So I mean, I shop at Amazon quite a bit. When I go and make an order, Amazon is presenting me a screen. Are you Prime customer? If not, here's your standard delivery. It may take 4 days, 5 days. So these are the interfaces that Amazon is giving me. That's abstraction as Amazon provider is providing to me as a customer.
Right.
I, as a customer, don't care whether it's getting shipped by a truck or by a plane, right? I care about is by my choosing of my time, my deliverables are there met. So that's the level of abstraction we're talking about. So if you take this concept and use the same concept for building the applications, for example, there is a slide called, next one called Open Application Model. What you're seeing here is this is again a CNC of project. The application part are the components. So let's say you're building a web service. That web service needs an ingress, a scaler, right? In a traditional infrastructure world, you would have to go and create Kubernetes resources, right? Services, deployments, create HPA, horizontal autoscaler policies, create secrets. But again, that's like you're forcing developers to think from the Kubernetes world. Can I think to an application-centric world? I need a web service. I declare my infrastructure needs in a declarative way. I need an ingress. In my workflow, I need deployment, either canary or a blue-green. Right. And here my policies for security scan check. Right. So that's the open application model. The components are the one that a developer is defining it. And on the right side, you as an operator, as a platform engineer, are the responsible for all the traffic management and identity. In a way, you have abstracted away all those details from the developers, and right. That's what they focus on the business logic. Right?
So that's perfect, and that's an ideal definition of like how a developer can leverage abstractions, right?
Yeah.
Now let's come to distributed SQL,
yes.
Right? And given the fact that we are at a Yugabyte conference, we'd love to understand how has Yugabyte helped you. But yeah. Before that, just wanted to thank you for highlighting the abstractions because we at Yugabyte embrace the same philosophy. Like we essentially work with largest of like media companies, automotive companies, financial services. Actually, day to day, most of your shopping goes through Yugabyte platform. Whether you're doing a shopping on Walmarts or Gaps or Home Depots of the world, all that traffic goes through Yugabyte, right? But the way we did that is essentially building a scalable, resilient data platform and bringing you two very popular APIs, right? It's a distributed Postgres API or a distributed key value API, which looks and feels like a Cassandra API as well. So with that in mind, help us understand how did you land at Yugabyte in your OAM model?
Yeah. So when when we were evaluating all the distributed Postgres offering in the market, right, there were choices like, for example, Google Cloud Spanner or a Cockroach DB, right? We looked at the core tenets of IDP, like which databases, again, when we're choosing our offerings, whether it's a databases or messaging or a lakehouse, we want to use through the same philosophy of how can I make my developers, the software engineers, focus on the logic that they want, that moves the company needle, that makes the company money, right? So again, Yugabyte plays as in a very open source OSS format. Others have restrictive licensing around that. So that's the business model of things. But on the technical side of things, I talked about, like, for example, standardized observability, right? If you can plug in with open telemetry, it gives you the right level of metrics and traces right out the gate, or the box instrumentation with Yugabyte. Right. You talk about the Geo application, disaster recovery. It has the plug and play to build just the right level of abstraction on top of Yugabyte to help that. So that's why we chose Yugabyte for our architecture in the platform.
Gaurav, I was thinking that you'll say you really like working with the teams like Valerie and Jim nicely, but thank you again for highlighting the technical and business results. So with that in mind, help us understand how does Yugabyte fit into your OAM model now from a technical perspective?
Yeah. So, on a couple of slides ago, I was showing you the generic slide for the open application model, right? Now let's use that slide and see how that we can use that for Yugabyte deployment. Right? So this is the concrete implementation of that, right? So think about that. Let's say, I am using the BYOC model, bring your own cloud model, right? A managed service of the Yugabyte is responsible for the deployment of Yugabyte universe, right? So that's their control plane. So on the left side, Yugabyte environment, they would install the managed offering. We would give them our GCP project. They would go and install through the control plane the Yugabyte universe, right? So that's managed by Yugabyte as an example. Now, on the right side of the screen, that's the control plane of your internal developer platform, IDP. What are you doing with this one? So you have, for example, I talked about the cross plane. It's a control plane for the Kubernetes external API. You can use the cross plane provider SQL to spin up all the assets. So for example, I can create databases. I can create appropriate roles and grants. These role and grants would go and, like, for example, let's say I'm writing an app developer. I want a database, right? I would specify in my infrastructure, in my YAML file, here's my database. The infrastructure under the hood, the cross plane and the operation model will actually install the database into the control plane cluster of Yugabyte environment, right, with the appropriate roles and grants and permissions. So you've taken away again, the same philosophy. You've taken away the concerns of an application developer into the platform itself. Right. And when you integrate with, let's for example, open telemetry, you again have gone one level up, where you have given them out of the box traces, metrics, and logs collection, right? So the developer will just focus on using the database to do their business logic, right? Same thing you can do with your database management schema. So you want to change a schema, can you centralize it? Can you put in the GitOps model? So cross-plane helps that in the 360 feedback loop cycle. So there's a desired state, here's my change state. It will redo the reconciliation and spin up the appropriate clusters on the BYOC cluster.
Right. So Gaurav, I would say that you've created a fantastic blueprint, and if you're able to replicate this blueprint for new business services, you're essentially making a lot of money by saving costs and operational overhead. So assuming that's a correct hypothesis, help us understand the impact that Yugabyte has brought to your own teams, development as well as businesses.
Yeah, so there are two columns here, one for developers, for one business. For developers, we're able to focus on the simplified operations. They have a consistent set of metrics, traces, and logs. It's a consistent dashboard. So if they want to take a look at what's my read IOPS, write IOPS, and stuff like that, they don't have to do anything in their code bases. There's an open telemetry integration with Yugabyte. We can focus on that. So they focus on the application business logic, and it accelerates the productivity of the developer. On the business sides though, right? So we have reduced time to market. We're able to get the same application that was taking longer time to ship. We're able to take over the concerns of operations around it, right? Incidents around it, so that it is measured with the right metrics, KPIs, and then you focus on the business logic.